In number 2, we have a new function. It tells me it's f prime equals cosine of natural log of x. It's the first derivative of a twice differentiable function. So I notice I have a new function, and it's a multi-part question. So my first step is to probably go ahead and just type it into my calculator. We go back to my y equals, clear out everything else that I had from my previous problem so it's not interfering. And then I'm going to go ahead and type in that function, cosine of natural log of x. Be careful with your parentheses here. These automatically fill in for me. Now it tells me on the interval 0 to 10, I want to find the x values where f has a relative maximum. So I know that that means I'm going to look for where f prime changes from positive to negative. So in other words, I need to find x-intercepts where I cross from above the graph to below, above the x-axis to below the x-axis. Before I graph, I need to think to myself, is there a certain window I need to be in? I notice I'm going from 0 to 10, so I want to be in the window from 0 to 10 for my x values, 0 to 10. That way I'm not putting in answers that aren't in my actual interval. For my y min and max, if you're not sure, you can definitely leave it as negative 10 to 10. But cosine is a function that is always between negative 1 and 1, and so my y values will be between negative 1 and 1. I want to see a little bit more, so I'm just going to make this go from negative 2 to 2, just so I can get a better picture of the graph. Sometimes you're not going to be sure what that is, so you can just take a look at the graph and then come back and edit your window if you can't see the things you need to see. So I'm waiting for this to graph. Again, I'm looking for where this function, which is f prime, changes from positive to negative. In other words, I'm looking for an x-intercept where I change from above the x-axis to below. So I'm going to be looking for this point right here. I change from positive to negative. That's an x-intercept. So I'm going to hit second calc. I'm going to find the 0. That's my x-intercepts. Now I need to make sure my left bound, I'm to the left of the 0, right bound to the right of the 0, and then hit enter for the guess. I see that happens at 4.810. So for my answer, I'm going to say f has a relative max at x equals 4.810, since f prime, that was our graph, changes from positive to negative. For part B, same idea, we're on the same interval. It tells me to find where f of x has a relative minimum. So that's a 0 where I change from negative to positive. I see that happens right here, somewhere between 0 and 1. I can do that same process, second trace, 0. Instead of using the blinker, especially if I'm pretty far away, I can actually just type in an x value. So I can see that this 0 is between x equals 0 and x equals 1. So for my left bound, I can just type x equals 0 and hit enter. And it's hard to see, but that line is actually right here for my first line. My right bound would be 1. And so it's going to find the zeros between x equals 0 and x equals 1. Just hit enter for my guess, and it has found that point. Make sure it's on that point that you were looking for. And so I'm going to say, just like in the last one, f has a relative min at x equals 0.207 or 0.208. You can round up if you need to. And our justification is since f prime changes from negative to positive. For part C, it asks me to find the x values where f has a point of inflection. When I'm looking at the graph of f prime, that's where f prime has relative maxes and mins. I see that this graph has a relative max right there, so that's the point I want to find. I could also take the derivative of this and see where it changes signs, but I already have this graph here, so let's find that max. What I'm going to do is hit second calc. I'm going to use maximum number 4. Now this doesn't necessarily find a relative maximum, it will find the biggest y value on whatever interval you give it. So I can see, it seems like the max is around x equals 1, and so this left bound is going to be fine, and then I'm going to move to the right of that maximum. Again, I could plug in an x value like 2, something like that. Hit enter. So this will find the x value and the y value at the biggest point on this graph. And double check it is where I want it to be. I see that my maximum occurs at 1.00000 something, and then y equals 1. Now on your calculator it might say 0.9999 or something like that, but that's still going to round up to x equals 1. My justification, f has an inflection point at x equals 1, since f prime has a relative max. All right, number 3. We are given a derivative, f prime equals x squared sine of x squared plus 2. If f of 3 equals 7, we want to find the value of f of negative 1. So this is when we use that net change theorem or fundamental theorem of calculus. If I want to find f of negative 1, that's equal to f of 3 plus the integral from 3 to negative 1 of f prime of x dx. Notice that this 3, that has to match up with the bottom number here. The negative 1 on this side matches up with the negative 1 here. So this is backwards, but that's okay. We're going to type it into our calculator that way anyway. So you do not need to graph this or put this in your y equals. This is just a single problem. I don't need to look at a graph. I'm just going to do some calculations. So I'm just going to go back to my home screen. To get an integral, I'm going to do math 9. So I'm going to do this f of 3 first. F of 3 is 7 plus my integral is math 9. That's going to go from 3 to negative 1. If I had put that function, the f prime, in my y1, I could use y1 right here. But I'm going to go ahead and just type in that function, x squared sine of x squared plus 2. You could have done this with derivatives too. We were using y1, but you can just type something in there and it will integrate it. So I do not need to write this on my paper, even though this is what I'm in my calculator. I surely can write that out, but because they told me what f prime was, I can leave this as f prime. I don't have to rewrite it. And then just hit enter, and it will calculate for you 7.338, or you could put 7.339. In number 4, we have a function f prime is x squared plus 2 times cosine of 2x minus 1. It asks us for the x-coordinate of the absolute minimum value of the function f on the closed interval 0 to 5. So we are going to be using EVT here. And so remember, that means we need to know our endpoints. We have those given from 0 to 5 and our critical points. So I need to see where this derivative is 0, first of all. So I am going to need to graph this to find those zeros. So go ahead and type this in. Be careful with your parentheses. X squared plus 2 times cosine of 2x minus 1. And then pay attention, I'm on the interval 0 to 5, so I'm going to change this from 0 to 5. I'm not totally sure what the y values will be here. Let's just do negative 10 to 10. Remember though, we're going to be focusing on, we're looking for zeros, so it's okay if some of the graph is cut out. We really are going to be focused on the x-axis. Okay, so I need to find my x-intercepts. Second calc, 0. Let's find this one. I see there's one between 1 and 2, so I'm going to hit x equals 1, x equals 2. So we'll find the 0 in between there. 1.285. So I'm going to write, you need to still write out, like I calculated f prime equals 0 when x equals 1.285. And then find the other zeros in the same way. So I want you to try that on your own. You should get 2.856 and 4.427. You can store these if you would like, but usually on these problems, it will be easy to tell which one is the biggest or the smallest, and so you don't have to stress if your answer is just a little bit off in the same way. But what we are going to do is evaluate our function f of x, kind of like what we did in the last problem. we're just going to integrate. I'm going to start with 0 because it's my left point. If you're given a specific value, you would start there, but we're not given any y values. So we'll go from 0 to x, f prime of t dt. So what that means is when I start out, for example, I'm checking my endpoints and my critical points. So I'm making my table of values. To find f of 0, f of x, I'm going to integrate from 0 to 0, f prime of x dx. And so that's my y1, but I know that this is just going to be 0 in this case because I'm integrating from 0 to 0. For the next one, I will go from 0 to 1.285. F prime of x dx, which means I'm using y1. So I hit, make sure you're doing your calculations on your home screen here. Math 9. I'm going from 0 to 1.285. And I'm using y1 because I had typed it into my y1. And so I get 2.207. Do those other same things for these other three values. So I'm going to go from 0 to this value. So 0 to 2.856, 0 to 4.427, etc. I will get negative 4.197, 11.180, and 3.814. So again, that's just integrating from 0 to this x value that they gave me. This was asking for the absolute minimum value. It was just asking for the x coordinate though, so I only need to give the x coordinate. That's why the y coordinate doesn't matter too much if I'm a little teeny bit off, because I'm really focusing on the x coordinate. So the smallest value I see is negative 4.197, but since it asked me for the x value, my answer is going to be 2.856. So I'm going to say f has an absolute min when x equals 2.856, and that will be my answer.